Okay, so first, what's up here on the screen, I want to point out, is the basics of trigonometry and some things that we should be familiar with from geometry, and I'll give you a chance to copy down what you need to copy down. Or if you're going to print this out when you go home, because there are a lot of other pages to it, too, that we're going to use later. Like, it might be, like, 10 pages long or something. 11, maybe. I don't know. I don't want to scare you guys. It's not all horrible. This is, like, my favorite unit ever. But if you're going to print it out when you go home and then you don't want to write this stuff down, then you're okay, all right? If you want to just take notes like normal, then you can take notes like normal. It's totally up to you. So in this box right here are the functions that we should be aware of. So sine, cosine, and tangent, and with them, they're reciprocals. So how many of you guys have heard cosecant before, used it before? How many of you guys think you've heard it before, but like you don't remember it? It has left your brain, but you're pretty sure like somebody told it to you one time. Okay, that's okay. All right, so but we know sine, cosine, tangent. Okay, those things have stayed with us. Okay, if you know sine, cosine, tangent, you know cosecant, secant, and cotangent. You just have to use the reciprocal. Okay, so I don't memorize new things. I just learn how they're related. But you guys already know this. Like I'm like anti-memorization because I just don't have a lot of space. So sine, okay, is opposite over hypotenuse in a triangle. In this triangle, from where our angle is, that would be A over C. So that's where they're getting those letters from. So it's just a demonstration for you of those things. The cosecant is the reciprocal of the sine, okay, which means it's going to be C over A. So you don't need to memorize the cosecant. What you need to remember is that if they ask you a question about the cosecant is related to the sine as its reciprocal. And then you can do the sine calculations, just flip it over when you need to. Okay, make sense? All right. And then you have your cosine, which was adjacent over hypotenuse in this triangle B over C. And its reciprocal is called the secant. Okay, so being the reciprocal of the cosine means like 1 over cosine, and it would be C over B in this triangle. Okay? And then lastly, we have the tangent, opposite over adjacent. So in this triangle where the angle is marked, that would be A over B. And its reciprocal would be the cotangent. So that would be 1 over the tangent, or in other words, flip over the fraction and get B over A. Is that okay with everybody? Most common error here, not remembering that the secant is the reciprocal of the cosine and that the cosecant is the reciprocal of the sine. Yeah, you can see how people can mix those up a little bit. Okay. So the way I try to remember it is like each reciprocal pair only has one name that starts with the co. Totally not mathematical, but it helps me remember. Like this already starts with co, so its reciprocal doesn't start with co because the pair only has one co in it, right? Co, okay? I don't know. It helps me. If it doesn't help you, let it go, right? Okay. Not in the frozen sense or whatever, okay? All right. Now every time I say that, people start singing, and I understand. All right. And maybe see some things we didn't do. Not exactly sure. Oh, those are proving triangles congruent. But we are going to use some of that information to help us understand this next law that we're going to study.
What's the one that doesn't work?
The one that spells a bad word, or angle, angle, angle? Do you know what I'm talking about? Okay. That's a bad word. It's a bad word to say in the middle of class. All right. So here we have a triangle. It asks us to find the value of the 6 trigonometry functions for angle theta. So here's angle theta. So this is our perspective. Okay? Whether that was our perspective or not, and these should have right angles marked in them. Sorry, guys. I know, we teach you never to assume, and then I put something up here where you have to assume. So I'm telling you that should have been a right angle, okay? All right, so this is for sure the hypotenuse. All right, so given where theta is, what is our opposite side? Jordan? 5. Okay. And that makes our adjacent side 12. Okay. All right, so to find the 6 trig functions means what they want us to do is they want us to find the sine of the angle, the cosine of the angle, the tangent of the angle, and then all of their reciprocals. So remember, the reciprocal of the sine was cosecant. The reciprocal of the cosine was secant. and the reciprocal of the tangent was cotangent. So go ahead and take a minute and fill those in. Leave them in fraction form. All right, sine theta. Julia. Over 13. Cosine theta. Grant. Tangent theta. Matt. 5 over 12. And how am I going to find these other three functions? Yeah, good. Just take the reciprocal. So do you guys understand? Like, you have to know which one goes with which, but do I have to memorize a new procedure for those or anything? No. I just have to know which one's the reciprocal of which. Okay? So we kind of recall setup and stuff like that. Are we good? Any objections if I change it? Good. So what the secant is used for are sometimes, if you don't, it's basically exactly what its definition is. We want to use 1 over the cosine. Say there's some situation, and when you solve for something, instead of getting what the cosine is equal to, you know that it's equal to 1 over the cosine. But because it's used often in things, we'll see later, things that are associated with wave type of motion, call that like periodic motion, they want a name for the reciprocal, because if you're using it, you don't want to have to keep writing 1 over the cosine of, maybe you're taking the cosine of a bunch of crazy stuff, then you just want to be able to call it the secant. Okay? So they're used in the same context, but just they show up in the lots of time when people are doing calculations and using them in real life, they would use the reciprocal, so why not give it its own name? Is that okay? Same idea. They could have, somebody could have at the very beginning decided to call these ones, someone defined these originally, They just happen to define these ones that we use more directly and these as the reciprocals, but they could have defined it either way. So they really stand for the same things. All right. Next problem says, find the tangent of A when the cosine of A equals 2 over 3 and there is no picture. Okay? But as far as what we know right now, if they're providing us with information like the cosine of A is equal to 2 over 3, what are they telling us? Matt? Okay. Okay, good. So cosine is usually adjacent over hypotenuse, and they told us this is 2 over 3. So Matt's saying, well, basically then, either the hypotenuse is 3 or it's some multiple of 3, right? Because the way that you get this ratio is either when they took the adjacent and the hypotenuse, they were literally the numbers 2 and 3, and that's how they put it together. Or maybe they were like the numbers 6 and 9, right? But then those get reduced to 2 and 3, okay? The cool thing about the factor part is we don't have to know whether it was 2 or 3 or 6 or 9, because that means the other side of the triangle, they grow like proportionally, right? So if these two had a common factor of 3, so would that other side, and we'll figure out what that looks like just in the most simplified form. So in the most simplified form, I have to actually build this triangle. Since the triangle has a hypotenuse, I'm going to give the triangle a right angle. Okay. Now, where is angle A? It technically doesn't matter. Angle A is just going to provide you the perspective to fill things in the right way. You can't make it the right angle, okay, because then you wouldn't have, your hypotenuse would also be your opposite, so that wouldn't really make sense. So it has to be one of the acute angles in the triangle. Which one is up to you? But once you determine which one it is, now you do have to put the 2 and 3 numbers in certain locations. Because if I said this is angle A, and we said 3 is the factor that we're keeping on the hypotenuse, does the 2 go across from angle A or next to angle A? So 2 represents the adjacent side, which would be there. Okay? So that's the part that I have to do correctly. Otherwise, when I go to find what they want me to find, which is the tangent of angle A, how do I calculate tangent? What pieces of the triangle do I need to see? Good. Opposite over adjacent. Okay? If I mix them up, I'm going to get my tangent wrong, right? I'm going to have the wrong ratio of sides. So it's important that wherever I put angle A, this adjacent one was. Now, if you put angle A up here, your 2 would be on the other side of the triangle, but you would still have adjacent labeled as 2, and your opposite would be whatever other number we get. Now, they didn't give us the opposite. We needed to find the answer, so what should we do here? Sure, Pythagorean theorem, okay, because we have 2 of the sides, and then we just have 1 missing. So Pythagorean theorem is like a squared plus b squared equals c squared. or in this case, some missing side squared plus 4 equals 9. So a squared is equal to 5, which means this side length would be rad 5. Okay. Is everybody okay with that calculation? I did it quickly because I figure you guys are like masters of the Pythagorean theorem. Okay. All right, so then when I put together my tangent ratio, my opposite is rad 5, and my adjacent is 2. This is the exact value, okay? Because if I use a decimal approximation for rad 5, it's just that. It's an approximation because I can't keep it going forever, okay? And remember, if the radical's in the denominator, do you leave your answer that way? No, you rationalize it. Okay, we talked about that first semester, and you guys talked about that in Algebra 1. Yeah?
I forgot. You only use trigonometry when you have, like, right triangles, right?
Yes. So far you guys have only seen trigonometry and right triangles. We're going to expand that idea to ways that we can use trigonometry to find things out about triangles that aren't right. And we're also going to translate into what it looks graphically and in a circle. But so far, yes, that's the only way you guys have seen it used. Okay? We're not going to do the triangles, so you guys have time at the end, hopefully. All right. So in all the problems so far, we set up a triangle, we identified the angle perspective, and we asked you guys to find the sine, cosine, or tangent. So when you were finding the sine, cosine, or tangent, you were finding some ratio of the sides, right? So your answer was some ratio, a fraction, some division thing, right, based on side length, okay, numbers of the side. This problem is completely different, okay? It looks similar. What is it different? What am I finding when I'm finding x in this problem? The angle. Okay, how do I know that x is an angle? Because you can take the sine of it, apparently, according to their equation, right? But remember, our sine function says, well, the sine of an angle is equal to opposite over hypotenuse. This is always an angle that you take the sine, the cosine, or the tangent of. So in this case, I'm trying to find x, and x is an angle. And that decimal that they're giving me, 0.7590, is something that came about when they divided the opposite and the hypotenuse sides of the triangle, and that's what they got. Okay? So this is not something you're supposed to know. So if you're sitting there going, I don't know what angle gives me a sine of 0.75, neither do I. So welcome to the club, okay? But we can figure that out using our calculator. I just wanted to see if we remember how we solved something like this from geometry. So how do we solve for x in this case? Matt? Good. Okay, and do you guys remember notation from first semester? If I called a function f, what did it mean if I did that to the function? Yeah, inverse. So there's on your calculator, there's a sign button. And as the second function of that button, the shift key of it, right, looks like this. And what are we going to call this? The inverse sign, because that's what that notation means, okay? So now it's a little more clear maybe in geometry why you were pressing that button, right? Inverses tend to undo each other. Like if we have 2x equals 12, a very simple equation, we solved this equation by dividing by 2, because what was happening to x is that it was getting multiplied by 2, and division is the inverse of multiplication, right? So it like undoes the multiplication and leaves us just with x. And then we do the same thing on the other side, and we get some value, okay? So the same idea is happening here. We have sine of x equals this decimal. Okay? We can't just divide by sine, because sine has no value alone, right? You don't say like, oh, yeah, calculate this, sine, okay? Sine of something, right? And then I can get a value. So I can't just divide both sides by sine because it doesn't make sense. Kind of like with logs, right? We could never just divide both sides by the word log because the word log by itself had no value. But like log of 10 means something, okay? So we can't just divide by sine. So how do we undo sine? Basically what's happening is this, and then I'll show you how we rewrite it. We're basically applying the inverse to both sides. But just like multiplication and division being inverses, they undo each other, right? So right here it's saying, oh, you started with something called x and you did this to it, okay, the sign. And then this is going to undo that. So what are you going to end up with? Exactly what you started with, okay? But what you do to one side of a function, you need to also do to the other side. Cody? Yeah, but it's not so. So we have to make this clear distinction between cosecant and inverse sine. They aren't the same. But in your guys' math history, these words are often used interchangeably, but the sine and the cosecant are what to each other? Reciprocals. Is being a reciprocal the same thing as being an inverse? Not all the time. Here, being the reciprocal is being an inverse because dividing by 2 is the same thing as multiplying by the reciprocal of 2, right? So in multiplication and division, inverse and reciprocal do end up being the same thing, okay? But in functions, okay, 1 over sine, still if you tried to do that to each side, you might think, oh, the signs would cancel out. But still, the sine by itself has no value. It's like the log. It has to be the sine of something. So if you did that, you'd have to have 1 over the sine of x multiplying sine of x. But then the problem is that's going to cancel out the whole thing and not leave you x, and now your sine x is just going to be in the denominator. Okay? So inverse is something different than reciprocal. Okay? Those are only similar to each other in multiplication and division, and that's purely because of the properties in our number system of multiplication and division. Does that make sense? So you guys really have to separate the words inverse from the word reciprocal because they're two different things. Okay, Monet? No, so that's exactly what Cody was just asking. Because 1 over sine is the reciprocal of the sine, and what do we call that? Look back at the first page of notes, right? So we call it the cosecant. So the cosecant is the same thing as 1 over the sine of x. But notice they both are of something. Okay? The inverse of the sine function undoes whatever it does. So basically, the sine function says, I take an angle, and I tell you what the opposite divided by the hypotenuse was from the triangle that's related to that angle, right? The inverse sine says, I take what you got once you divided the opposite over hypotenuse, and I give you back your angle measurement. That's totally different than just flipping over the side lengths. Okay? So, like, let's say we have this triangle, right? I'm going to do one that we know. So if you guys remember your 45, 45, 90s, if this is 1 and this is 1, then this is rad 2. Okay? So in this triangle, if you calculated the sine of 45 degrees, you would do opposite over hypotenuse. So you would do this. And then you would never leave your final answer like that. You'd fix the radical. But just so we can see the relationship, I'm going to leave it like that for right now. If I were to find the cosecant of 45 degrees, that means instead of doing opposite over hypotenuse, I'm just going to do hypotenuse over opposite. Okay? So it's going to give me this. But notice, sine takes an angle and gives me side lengths. Okay? Cosecant also takes an angle and just gives me the side lengths in a different position, a different ratio of them. Okay? The inverse does something completely different. If we wanted to write an inverse for this problem, we would say remember, when you take an inverse, you plug in side length and you get out an angle. So here, this would have to say, like, what is the inverse sine of 1 over rad 2? And that would be asking me the question, which angle got this as its sine? And so I'd look over here and I'd say, oh, there's that answer. That was the sine of 45 degrees. This is a 45-degree angle. Okay? So the inverse function takes what you used to get as your answer and now says, if you plug that in, I will tell you what the angle measurement is. The reciprocal just does the same thing the sine function does. It just does the ratio in a different order. Okay? So in this problem, if you're trying to solve for x, you're trying to solve for an angle. This does not produce an angle. It still produces side measurements. So inverse and reciprocal are two different things. Do you guys understand that? Okay? Like, for example, 1, the number 1, okay? Or 1/2. What's the reciprocal of 1/2? 2 over 1, right? What's the additive inverse of 1/2? Negative 1/2. Is it the same as the reciprocal? No. The multiplicative inverse happens to be the same thing as the reciprocal of the numbers, and that's why you guys mix them up, because in the past, you've used inverse in that context, and you need to understand that's only true in that one context, and you need to let go of it and know that reciprocal and inverse are two totally separate things, okay? All right? So if you want to solve for an angle, reciprocal functions aren't going to give it to you because they still give you side length, okay? If I want an angle measurement, I need to use the inverse. Now, you wouldn't calculate this by yourself. Later on, there's going to be some special ones that we are going to know, and we're going to be aware of some relationships we didn't know before. But currently, this is something we would totally plug into the calculator, all right? So where your sine button is on your calculator, this sine inverse is the second function of that, and it's going to wait for you to take the sine inverse of something. And what you're taking the sine inverse of is always some ratio of sides, and then it should give you an angle measurement as your answer. Now, one thing to be aware of, we're looking for an angle measurement in what type of units? Degrees. So you need to make sure your calculator is in degree mode. So hit the mode button on your calculator, and there's going to be a degree radian row, and make sure that you have degree highlighted, and then do this calculation. If degree wasn't highlighted, redo the calculation, and then it should make some more sense. So those of you in chem especially, okay, and as you got to be careful, okay, because different places your calculator needs to be in different modes possibly. There's one row that says degree and radian.
Oh.
So when you guys press mode, it has a bunch of different rows of information. One of them says degree radian. Go highlight the degree and press enter. So what did you guys get for your answer? 40 what? 9? Yeah, we're good. Okay. All right, so why do we use all this stuff? We use all this stuff to solve for different things in triangles. All right, so what we're going to do is we're going to go through right now, we're going to solve 2 triangles. Okay? And again, I'm sorry, the right angles should be marked and they're not. First of all, what does it mean to solve a triangle? So I'm not asking you for something specific, I'm just saying solve the triangle. What am I asking you to do? Raven? Good. Find any missing angles or sides from the triangle. So in this case, to solve our triangle, they've actually already given us all 3 sides. If they only gave us 2 of the sides, how could I get the 3rd side? Pythagorean theorem, right? But then the bummer here is even with all the sides, I know that the degrees of a triangle add up to 180. This one's 90, which leaves me 90 more, but how those 90 degrees split up here, I don't know. I know that angle B should be smaller than angle A. How do I know that? Get it? Good. Okay. And that doesn't really help me solve it, but it could help me check the reasonability of my answer, right? If I get something really large there, that doesn't make sense. Okay. So this is where I'd want to use trig, and I know that I have to use trig because I have sides, but I don't have anything enough about the angles to just use angles to figure them out. So I have to use the sides to figure out angles, which means trig. What angle do you guys want to solve for first? It doesn't matter.
I have a question.
Yeah.
It was, I remember in geometry,
Uh-huh.
groups of side lengths
Uh-huh.
that gave you, like, as to which the angles would be.
I don't know if there's necessarily groups of side lengths that tell you. For 30-60 90s and 45-45 90s there are. Otherwise, you don't really know. The only groups of numbers that I recall, and I did teach geometry for several years, but I could be wrong, are like the Pythagorean triple numbers, or you would have, yeah, but that's just about the lengths of the sides. That's not about angle measurements. So then the only reason, without trig, the only way side lengths would give us some hint to the angles would be if the sides showed up as the sides we expect to see in a 45-45 90 or a 30-60 90, then we would know, oh, our angles are 45-45 or 30 and 60, and then we'd put them in the right spot. But this isn't that case because the smallest one is not half of the hypotenuse, so it's definitely something different than those 2. All right, so which angle do you guys want to find first? It doesn't matter. A? Sure. The only reason I ask you that is because I want some focus, okay? So A is what we're going to focus on. So whatever trig function we use, and again, I know I have to use a trig function because I don't have enough about the angles. I'm going to take the sine, the cosine, or the tangent of angle A and set it equal to the ratio of the sides. Now, they gave us all three sides. So do we have to be picky about whether we're going to use sine, cosine, or tangent? No, because you could find the sine of angle A, right? You could find the cosine of angle A. You could find the tangent of angle A. So we can use whatever you guys want because they gave us all of them. Keep in mind if they didn't, maybe if they only gave us those two, okay? Like if they only gave us this and this, then we would probably want to use what trig function? So sine, cosine, or tangent? Sine, because this would be the opposite in the hypotenuse, so that would be my best setup. Now here you don't have to do that because they gave them all to you, so you could set up however you want. What do you guys want to use? Tangent? Sure. Okay. So the tangent of angle A is going to equal opposite over adjacent. Okay? So opposite in this case is 12, and adjacent is 9. So 12 over 9. Am I solving for an angle or a side length? Angle. So what am I going to have to use? The inverse. Good. The inverse helps us find angles. So angle A is going to be found by taking the inverse tangent of 12 over 9. Okay? And so that's what I would type into my calculator. So somebody tell me what you get. 53. So the measure of angle A equals 53 degrees. I do not need to use trig again then to find angle B, because now I could use the fact that the angles of a triangle add up to 180 degrees and figure out that angle B should be 37 degrees. Okay? So my solutions here, the only two things that were missing were these angles. And do they make sense? Okay? Are the side lengths in places the hypotenuse is the longest side, smallest angle is across from the smallest side? All that should make sense at the end.
I also solved angle B and I got 36.86, blah, blah, blah. So, like, should you always round up if you get, like...
It will say, here it said round the sides to the nearest tenth and angles to the nearest degree. So you would round yours to 37 because it was 36.8, and then you'd have the same answer as us. So you shouldn't always round up. It depends on what they're asking for or how exact you want to be. If it doesn't say, I would at least go a tenth, usually. Okay? Yes?
If they ask us like to find all the angles to the nearest degree, even though it's given, like can you imagine, should we still write it? Because they ask for all angles?
No, because it would have to be given that angle C. So to solve it just means to find the missing pieces. So as long as you list the missing pieces, you'll be fine. All right. In this triangle, Z is supposed to be 90 degrees. Sorry. Okay, so we are supposed to solve this triangle as well, but this time we have three things missing. We need to find the measurement of angle Y. We need to find side YZ, and we need to find side XZ. Matt.
Y equals 27.
Okay, so Matt says that Y is 27 degrees. Is everybody good with that? So we didn't have to do any trig to figure that out, just the basics of how many degrees are in a triangle. Okay, now YZ and XZ can't be found using Pythagorean theorem because we don't have how they're related to each other. We don't have two of the side lengths. So this is my hint to use trig because now I have a lot of angle measurements, but I don't have all my side measurements. Okay? So which side do you guys want to look for first? I don't care. Someone just throw one out there. XZ? Okay. I don't know if I heard it right. So maybe I just made it. Okay, XZ. All right, so if we're looking for that, okay, we have this other length that's the hypotenuse. And you need to choose an angle that you're going to use as the angle that you're taking the trig function of. So you need to choose to focus either on the 27-degree angle or the 63-degree angle. So what's it going to be? I don't care. This time I'll try to listen better. Okay, so you want to use sine. So you want to use the 27. Okay, so if you pick the 27, see how she strategically picked sine, because from the 27 we already know The side length of 23 is the hypotenuse, and that makes this side length that we're looking for the opposite. So we would want to use sine from 27 because that would put our missing side over 23. So we could set up the sine of 27 equals what I'm looking for, which is xz over 23. And xz is not two variables, it's just the name of that segment in the picture. Okay? So then to solve this, I would just multiply both sides by 23. And in my calculator, I can find 23 times the sine of 27 and have that side length. And this time it says, for the side length, it's said to the nearest tenth, so that's 1 decimal place. So what do you guys get for xz, Matt? Because this is what I'm trying to solve for. And it's over 23, so if I'm trying to isolate that and get it alone, I would times by 23 to cancel that out. And so then if I do that on one side, I have to do it to the other side. Is that okay? So what did we get when we did 23 times the sine of 27? 10.4? Good. Do I have confirmation? 10.4? Good. Okay. So now we know that this is 10.4. All right, so then what are your options for figuring out YZ?
When you're trying to find the sides, do you still leave your calculator on degree mode?
Yeah. When you're trying to find your sides, you can still leave your calculator on degree mode. So degree and radian mode is not going to mess you up during normal everyday calculations. The only way you're actually going to see the difference in the mode is if you're doing something that involves angle measurements, and we're going to learn what a radian is later, because there are two ways to measure in degrees or in radians for that angle position. And so the only time you're going to see it really matter is here. Now, it does matter, sorry, let me correct myself a little bit. It does matter if you're doing this calculation to find the side length. So this should still be in degrees because you're putting an angle in that's in degrees. But if I'm just like using Pythagorean theorem or something like that, it doesn't matter because that has nothing to do with angles. Okay? So any calculation that involves an angle, whether you're finding the angle or finding the side, if you're doing sine, cosine, or tangent of something, your calculator thinks whatever mode it's in is what you're putting in. But so far, you guys are only putting in degrees, so you want to make sure that you're in degree mode. Okay? All right. How are we going to find YZ then? Okay, so you have a couple of options. You can set up the cosine of angle 27. What else can you do? Or you can use Pythagorean theorem. All right? So go ahead and find YZ, compare it with somebody, and then we'll check and see if we all got the right answer. Again, you could use Pythagorean theorem or trig to find that last missing side length. And just a small reminder, if you ever set up some trig equation, so this is not from the problem we just did, but let's say you had like this. Okay? How would you go about solving for x in this case? Hannah? Okay, so we could divide by 8. So then we get this sine of 25 over 8. But is that equal to x? It's equal to what? 1 over x. So then what do we have to do?
Divide 8 by the sine of 25.
Yes. So we basically have to take the reciprocal of each of the sides, right? If we want this to be x, then this has to be 8 divided by the sine of 25. Okay? Does that make sense? Right? So you guys can see it that way. You can also see it this way. Whenever x shows up in the denominator, I know that one of our word problems also, like w showed up in the denominator, or L when you were finding like the length and width of something. Okay? When that shows up, what you can do, instead of getting rid of the 8, what you can do is get the x so that it's not in a position where it's in the denominator. So you could multiply both sides of that original equation by x. Now, yes, that will cancel x out, but it's okay because x will just show up over there on the other side of the equation. And then you can divide by the sine of 25. Okay? Just pointing that out because I often see that once people get reminded and review this, they're good at setting everything up, but then sometimes they struggle with solving when the variable's in the denominator. So just a small reminder of how to do that. Okay? So your homework tonight is all this, which is all review.